This video will show you how to create and use a custom moderator in the Improved Performance Research Integration Tool, or IMPRINT. IMPRINT stands for the Improved Performance Research Integration Tool. It is a manpower, personnel, and training prediction tool owned by the U.S. Army Research Laboratory and developed by Alion Science and Technology. It is freely available to U.S. government employees and contractors. In this example, we are going to pretend that data has been collected that indicates that performance on visual tasks decreases in poor lighting conditions, especially for intensive display monitoring missions. As a result of this new data, we want to create a new moderator for degrading visual task performance in poor lighting conditions and apply it to our already developed IMPRINT mission. The monitoring mission is a simple looping mission that has been previously developed. We will go into IMPRINT, open the model from the start page, and look at the mission criteria. This is the start page that you see when you first open IMPRINT. You can start a new analysis or you can open a recent file using the panel to the left. We're going to open a recent model called Monitor Mission using the recent file list. Once I locate my model, I just simply click on the name of it and IMPRINT will close the start page and open the model. You can see that my analysis tree has been expanded and a mission named Monitor Targets is displayed beneath the Operations Models node. If I double click on the Monitor Targets, it'll open the mission description window. From here I can enter the mission name, a description, and the mission criteria. For this example, the mission name is Monitor Targets, and the description is Simple Looping Mission to Monitor, Select, and Report Information for 10 Targets. The mission criteria consists of the time, accuracy, and mission criteria. Here, the mission criteria must meet the time requirement of 10 minutes 90% of the time, and the accuracy requirement that mission must complete without abort 100% of the time, and the mission criteria of having to meet both time and accuracy 90% of the time. Each operational mission in IMPRINT should have one or more warfighters defined. These are the entities that perform the tasks. In this model, there are two operators defined. The first is named Model Tasks. This is an automated operator that is assigned to any task not performed by a human. It does not accrue workload. And the second is named Target Scanner. This is the operator that performs the monitoring tasks in the model. You can go view the operators by expanding the warfighter and operators nodes in the analysis tree. Back in IMPRINT, to view the defined operators, first expand the warfighters node by clicking on the plus symbol, then expand the operators node. You can now see the two operators, Model Tasks and Target Scanner. You can also see that Target Scanner is the default operator. That means for any new task, this operator will be assigned to perform the task by default. If I double click on Model Tasks, the operator description window will open. From here I can see that he's marked as automated. Automated is true. And all workload management options are unavailable. If I click the tasks nodes, I can see that all automated tasks will be gold in color. By double clicking the Target Scanner operator, I can see that he is not automated. The automated is false. The specialty is 35F Intelligent Analyst, and the workload threshold is set at 60, with no workload strategy assigned. If I click the Task Nodes tab, I can see that all tasks assigned to this operator will be plum color. Next, we will look at the task diagram to see what tasks are performed during a mission. You can either click on the Mission Diagram tab in the Descriptor window area, or you may select this window using the View menu, then selecting Windows, and then selecting Network Diagram. Back in IMPRINT, we select the Monitor Targets Diagram tab. From here we can see the tasks that have been defined in this model. The automated non-human tasks are displayed in gold and are the model start and end tasks. The three middle tasks are the operator tasks performed by the Target Scanner operator. I can see that the mission starts, and then the task monitor screen for targets occurs, followed by select target, and finally by read report target information. I can see that this task, task 3, then either goes to the end node or back up to task number 1. I can review task information by double-clicking on a task. For example, if I double-click on the Start task, the task description window for that task will open. There are 8 tabs in the task description window. From the first tab, Time and Accuracy, I can see that this is a zero-time task that has 100% probability of success. Clicking on the Crew tab, I can see that this task is assigned to our Model Task Operator. If I click the right arrow, I can go to the next task, Monitor Screen for Targets. This task has a mean time of 30 seconds with a standard deviation of 10 seconds and is assigned to our target scanner operator. Going to the next task, select target. It's also assigned to our target scanner, and the time it takes is 2 seconds with a standard deviation of 50 milliseconds. I then go to the third task, read report target information. It has a mean of 15 seconds with a standard deviation of 3 seconds, and if we go to the crew tab, I can see that he's also assigned to our target scanner operator. For this task, if I click on the Paths tab, I can see that there are two possible paths that it can go to. It can either go to the end task or it can go back to task 1. It will go to the end task if our variable called target count is equal to 10, and it will go back to task 1 if our target count is less than 10. If I go to the Effects tab and look in the ending effect down here, I can see that that variable target count gets incremented every time this task ends. Close the task description window by clicking the X in the upper right corner. The next thing we want to look at is what the taxons are for each task. So let's click on task 1 here. We'll hit the taxons tab, and we can see that this task is 70% visual and 30% cognitive information processing or problem solving. Our second task, select target, is 30% visual, 35% cognitive, and 35% fine motor. Our third task, read and report information, is 40% visual, 20% cognitive, and 40% communication. So all three of our tasks have some visual component to them. Now let's run our model 10 times and look at two of the reports, the mission performance and task performance reports. Before running the model, it's always a good idea to check each model for error by clicking on the check mark, Check for Errors, on the toolbar. IMPRINT will check the model and report any errors in the output window. If there are no errors, it will say no errors found, simulation created successfully. Next, let's open the execution settings window by clicking the settings icon on the toolbar. From here, we can set the model to run 10 times. By default, it's set at 1, so we'll go in here and make this a 10. To run the model, then, we just click the play button on the toolbar, and it will generate the model and start it running. You can see out in our output window, it ran all 10 runs and shows you the end time. So it took real time 0.97 seconds to run all 10 models. To view the results, we select Operation Results under the Reports menu. IMPRINT will bring up a window that lists all the available reports. Let's select the Mission Performance Report and the Task Performance Report. And then click OK to tell IMPRINT to generate those reports. So IMPRINT will generate the reports in Open Excel to display those reports for us. So our first report is the mission performance, so we can see over our 10 runs the minimum duration was 6 minutes 30 seconds, the maximum was about 8 minutes 49 seconds, the mean of 7:41. It passed all of our time requirements, our accuracy requirements, and our mission requirements. We have a pass on all those times. So let's go look at our task performance report just by clicking that tab at the bottom of the Excel. So from here, if I scroll over, I can see that my 3 operator tasks, the first one met its time requirement 88% of the time, the second one 98% of the time, and the third one 83% of the time. It also shows me for each task what the minimum, maximum, mean, and standard deviation were. Now we are going to add a custom moderator using data from our experiment that will impact our task performance for any visual tasks. To add a new moderator, right-click on the Analysis node and select New Custom Moderator. In IMPRINT, I right-click on the top Analysis node, go down to New Moderator, then select New Custom Moderator. You can see that IMPRINT added a custom performance shaping node with a new custom moderator node below that. If I double click on the custom moderator, it will open the description window. From here, let's change the name from custom moderator to something more descriptive like lighting. Next, we need to add levels. So let's click the Add Level button and change the name from Level 1 to our condition, which is poor lighting. Next, we need to add an algorithm that describes how poor lighting will impact accuracy or time. Our fictional data only shows that the impact is on time. So let's open the time algorithm window by clicking in that cell and then clicking the little ellipsis button. That will bring up the moderator code editor window. Whatever was returned for each task in this code window will be added to 1 and multiplied by the calculated task time, thus increasing the task times. According to data from our fictional performance study, entirely visual tasks have a baseline time degradation factor of 25% when they are performed in poor lighting. To represent this, we need to type return followed by task dot, and then we're interested in the visual taxon, so we go down and select that. And then our degradation factor is 25% or 0.25, so we're going to multiply it by 0.25 and then add a semicolon. You notice when I type task and then dot, IMPRINT displayed a list of task attributes that can be used in code for custom moderators. In addition to having access to the 9 taxon weights, you can also access a single task workload demands for each task. If a task has a visual taxon weight of 1, you would expect it to take 25% longer to complete based on the code I entered. From here, I can also check syntax of the code I just entered by clicking the button. Here it came up and told me my code compiled successfully. Now we are ready to apply the new moderator to the model and determine the impact of the moderator on overall mission times. To do this, you need to tell IMPRINT which task the moderator will be applied to, select the level to apply, and enable PSFs during model execution. In IMPRINT, open the PSF window by clicking the Performance Shaping icon on the toolbar. From the Settings tab, we specify what PSFs to apply. There's a lot of built-in PSFs listed on top, and then our new lighting custom moderators on the bottom here. We want to make sure all the other ones are off and that our lighting one is on by checking the box next to that. We can also turn on the PSFs, enable PSFs by checking the box at the top. This will make sure that our PSF adjustments are used during the model run. Our new moderator impacts tasks, so we need to go to the Task Data tab. And from here, check Enable PSF for our 3 operator tasks. And then in the lighting column, we want to select poor lighting conditions for all 3 of these tasks. Now we are ready to execute the model with our PSF. Once again, we will run it 10 times and open the mission performance and task performance reports. Run this model by clicking the play icon. Once all 10 runs are complete, we'll go open the reports by going to the Reports menu, picking Operations Results, selecting our Mission Performance and Task Performance reports, and clicking OK. IMPRINT will generate the reports in Excel and display them. If we compare the results in the mission performance report from the baseline to the moderator runs, we can see that the minimum, maximum, and mean durations all went up. This is because the moderator made the task time longer, which in turn caused the mission times to increase. Looking at the task level performance, we see the same thing. The task durations went up and the percentage of times the task met the time criterion went down. Thank you very much for viewing this video. If you do not already have IMPRINT and would like a copy, please contact ARL using the really long email listed here. Happy modeling, everyone!